Okay, so now the cost function, and the more equations we add on, we're kind of approaching some homework problems and other concepts related to the previous. But let's just jump into the cost function and define an isocost and define the, basically the equations that go with cost. So the cost function, as mentioned earlier, the goal of the firm is to maximize its own profit. To achieve this goal, the firm first needs to understand how to produce its output, at the lowest possible cost. Hence, in this section, we want to answer the following question. If the firm wants to produce a certain output target Q, what is the combination of inputs that achieve this target at the lowest possible cost? So isocost, this is going to be a graph kind of like the isoquant. The isocost will be a y equals mx plus b, a straight line. Yeah. But now we define the isocost. Consider a firm that uses inputs labor L and capital K. Recall that we take these variables to be flows. We will denote W as the price the firm needs to pay for using 1 unit of labor, and R is the price for using 1 unit of capital. You can think about W as the wage paid to workers and R as the price of renting 1 unit of capital. If we are measuring L as the number of hours, then W is the wage per hour. If L measures 1 full day of work, then W is the wage per day. They kind of go on like this, but of course, everything technically, I think we can ignore this. W is a function of time. This just goes beyond the class. It's meaningless. Labor is a function of time. R, which is the rate for renting capital or something, or using capital, is a function of time. I don't know if capital is a function, but anyways, so there are functions within the function we don't need. It's just everything agrees in there as the same time period. Therefore, it can also be independent of time. So everything is along a timeline, but we can assign that timeline anything that we want to. If L measures 1 full day of work, then W is the wage per day. The same goes for the price of capital. In this chapter, we are focusing on perfectly competitive markets. This means that the firm so they kind of go through this. Let me kind of give my interpretation of this thing here. Yeah, so we're going to have that. But this is the basic cost function. You see below that they kind of derive a y equals mx plus b. Yes, but we say that labor is labor. Yeah, so if you have a certain quantity of labor, maybe it's a certain number of workers. You see, there's different ways that they can define it. It's just the overlying concept. This is really the theory. There is more than one way we can do it, but units of labor. A unit L might be literally number of people or something. They do sometimes keep it ambiguous in these books, but W is of course the wage per worker. So W equals wage. Yeah, so something like WL is the total amount of money that we spend on labor. So R they sometimes call rent. I'm just writing this stuff randomly everywhere. In real life, capital, it does not cost rent, but it might cost rent to rent or use the capital. Or if you don't rent capital, whatever costs a company actually using the physical items, the capital, they call that rent. And of course, K equals the capital. Yeah, so what would RK be? If K is the amount of capital and R is the money spent per capital, uh, then that's going to be the amount of money. So the cost is just, of course, WL plus RK. That's going to be the total cost for a simplified company here. Yes. Okay, so we have the cost function, and then we go down here and they just algebraically solve it for K. Yeah, so what do we have? We have a y equals mx plus b. This is what's going to be called an isocost, the straight line. Specifically, this is the isocost, yeah. Uh, where this is the vertical axis, the y-axis is going to be k as a function of L, And if k equals that, what is the slope? It's going to be negative w over r is what the slope is going to be. C over r is going to be the y-intercept, which doesn't have as much meaning. Yes, but basically this is the cost function, and when we graph it, it's usually capital as a function of L, where things like we have cost, rent, and wage all in there, but they make it into this y equals mx plus b. So that's basically what's going on there. So with this arrangement, we can draw a graph with k on the vertical axes and L on the horizontal axes, and connect all mixes of L and k that yield the same cost. Yeah, so it's an isocost. So we just did that graph right there. And every combination of labor, everything is clear. R and W are clear, but it's kind of like, what is that capital C? Capital C can change the cost, but all of the values were on that one isocost. So when I drew it just now a second ago, I forgot to mention that one very important thing. Just like the isoquants from the previous section, why would they call this an isocost? Yeah, because if this is L and this is K, yeah, this value of L and K will yield this isocost. This value of L and K will yield the same isocost. Yeah. Uh, but the cost is the same for all values of L and K on that thing, where W and R are constants, yes. So that's why they called it an isocost, because as long as we're on that same line, then as long as we're on that same line, the cost is going to be the same. Now we have isocost. This is coming up next. I always tend to get a little bit ahead of myself. If I write a little bit messy, it doesn't make sense. But remember, the isoquant comes from the Cobb-Douglas. Let's draw this a little bit better so we redo it. Yeah, if we have an isoquant, yeah. And then if we have an isocost, yeah, we're going to have that where the slope of the isocost is negative W over R. And we know that we're just going to have I already kind of forget, but it's not called the MRS, but the thing from the last thing, MRTS, yeah, is going to be reflective of the slope of the isoquant. The one point where an isoquant and an isocost, that one point where they intersect, that's the whole point of basically both of them. We want to be at that point where they intersect. So that's kind of a basic point that we're trying to get at here just a little bit. So this kind of introduces the isocost. I'm going to end up repeating stuff in the next video as always. The videos always overlap. But let's just let's go ahead and continue in the next video. Okay.